Welcome back, old school car audio friends. Many of you played the game about guessing the output power of the Concord CA 200.2, and today I am happy to present the real output numbers of this beautiful amplifier. This nice piece of car audio made by Harman Kardon back in the 80s has been sent to me by Sasha D. Thank you very much for supporting my channel. The amp is rated 200 watts per channel into a form load at 0.06% of THD. The features are simple. Just the battery connectors, the RCA inputs, a gain knob and a bridge mode switch. Pushed in means normal mode and out means bridged mode. The amp features nice speaker terminals which I only saw at Pro Audio amplifiers. I never saw an amp like this, and I want to say thanks for all the comments you made providing some nice information. And now let's start the dyno.
The amplifier is connected to the dummy load and I start carefully with a burst power test. I take 1 kHz 20 cycles like in the Rockford Fastgate burst sheets. 1 kHz 20 cycles. I catch the burst and have a look at the first cycles. Looks okay. So I'm going to the last cycle, check if it's clip free. Yeah, that looks okay. So what voltage do we get on the last cycle? I always measure on the last cycle. So we have, let's say 88.8 volts. By the way, I forgot to mention that I have connected an 8 ohm monoload to the amplifier to test the output power into a 4 ohm load, both channels driven. And I got 505 watts into an 8 ohm monoload. That means I have more than 250 watts per channel into a 4 ohm load of dynamic power. The Concord delivers an output power of 252.8 watts into a 4 ohm load per channel, both channels driven. Continuous power test 1 kHz. So in this case we have an output voltage of 88.8 volts. That means we have no dynamic headroom. The continuous power is the same like the dynamic power. We also have 252.8 watts into a 4 ohm load per channel, both channels driven. Continuous power test with a 50 Hz input signal. Let's have a look what we will get. High output voltage. There we get bad signal. That's almost okay. I will take this. It's not easy to catch the nice waveform, but the amplifier still puts out 88.8 volts. That's amazing. Even with a 50 Hz input signal, the amplifier puts out 252.8 watts into a 4 ohm load per channel, both channels driven. The amplifier didn't deliver dynamic headroom with 20 cycles and 1 kHz, so I jumped directly to 1 cycle 1 kHz. Let's check out if we have a higher output voltage. And yes, we have. For just 1 millisecond, the amplifier has an output voltage of 94.8 volts. For just 1 millisecond, the amplifier delivers 288 watts into a 4 ohm load per channel, both channels driven. Dynamic burst power test with 8 milliseconds. We get some clip-free voltage. Here we go into clipping. 90.6 volts. The amplifier delivers 263 watts into a 4 ohm load per channel, both channels driven. Now it's unloaded and I drive the amplifier to the clipping point. Still no clipping. The amplifier pulls. Now I'm at clipping. I reduce a little more. That's it. We have 58 amps and 14.38 volts. The amplifier has an efficiency of 60.5% if tested with continuous power, and also 60.5% if tested with 20 cycles 1 kHz dynamic burst power, because it has no dynamic headroom with 20 cycles. So I don't know if the amplifier can handle a 2 ohm load per channel. I start with a 4 ohm monoload, that means 2 ohms per channel, both channels driven, and I will start carefully with a dynamic burst input signal of 1 kHz and 20 cycles. Dynamic burst power test, 20 cycles with a pause of 480 milliseconds, reduced signal 10%, and now I start to catch the cycle and I go to the first and check it out. That looks okay. I try to increase a little more. And we have bad output voltage. You see this here and there. This is what I would call okay. We are at 75.6 volts. I go to the last one to have a legit test, and I see the voltage is sagging a little bit or goes into clipping. Yes, this is not what I am going to accept. All cycles have to be clean. I reduce more to have a legit test. I would say let's calculate with 70.2 volts. With a dynamic burst input signal of 20 cycles, the amplifier delivers 316 watts into a 2 ohm load per channel, both channels driven. One cycle with 1 kilohertz. That's okay. And I got a voltage of 84.6 volts. For just 1 millisecond, the amplifier has an output power of 459 watts into a 2 ohm load per channel, both channels driven. Dynamic burst power test with 8 cycles every 32 milliseconds. Let's have a look. So I go to the last cycle as always and observe for clipping. It looks, by the way, burst, pause, burst. Now I increase input signal. So there we go into clipping. Not clear, not clear, not clear. That's clear. So I got a peak voltage of 73.2 volts. With 8 cycles, the amplifier delivers 343.5 watts into a 2 ohm load per channel, both channels driven. Continuous power test 1 kilohertz into a 2 ohm load per channel, both channels driven. And as always, I increase until the signal looks bad. There it goes into clipping. I reduce. That looks okay for me and clean. We have a peak voltage of 70.8 volts. The amplifier delivers 321.4 watts into a 2 ohm load per channel, both channels driven. Continuous power test with a 50 Hz input signal. Clipping, it looks bad. That's okay. 68.4 volts. The amplifier delivers 299.995 watts into a 2 ohm load per channel, both channels driven. Let's say the amplifier delivers 300 watts. Now it's unloaded with 14.49 volts and you see the idle current of around 2.8 amps. And now I give full power, 1 kilohertz continuous power, and the amp is pulling 88.7 and 14.33 volts, 88.5. The amplifier has an efficiency of around 50% if driven with a 4 ohm monoload, that means 2 ohms per channel.
Thank you very much for watching. See you next time for another amp dyno video. Bye bye.